In this video, I'm going to be introducing you guys to solutions to differential equations. Now, if you already know how to solve differential equations, this is not the video for you. But if you don't know what a solution to a differential equation is, this is perfect. So, in the previous math class you've taken, you get like a number for an answer, right? You can get like 5, solve some integral, maybe the integral maybe the integral is 5, right? But the thing about differential equations is that your answer is a function. So your answer is a function. So throughout this video, I'm going to explain what that means. But let's first talk about a little bit about algebra. So in algebra, if you want to solve this, of course, you have to add plus 5 to both sides, and you get x is equal to 5. And of course, this is a very introductory algebra problem to solve. But in a sense, you get the answer as a number. Your answer is a number. But the thing about differential equations is that your answer is a function. So y, by standard notation, is just equal to some function of x, let's say. And y prime is just the first derivative of some function. Also, dy dx is another way to represent this. And you see double prime here. So let's talk about double prime. Double prime is simply the second derivative of some function and can be represented with Leibniz notation like so. So what is a solution to this differential equation? Well, I'll give you an example, okay? And the example I'm going to show you here is e to the t. Sorry, let's use x because x is the dependent variable here for this function. Independent, not dependent, blah. But let's look at e to the x. Is e to the x a solution to this differential equation? Well, how do you test that out? How do you know if e to the x is a solution, right? Because remember, e to the x is a function. So let's look at e to the x and let's consider it. So e to the x is just the original function. It's y, or f of x, correct? So if we plug in e to the x right here into y, we should get e to the x minus 0. And let's go ahead and plug in the double derivative of our function, right? Of our function y. And in this case, our function y is e to the x. Okay, let's go ahead and test this out. So the second derivative of e to the x is an identity, right? So if you take y prime, still e to the x. And if you take y double prime, it is still e to the x, right? So y double prime is just e to the x. E to the x minus e to the x is 0. So this right here is a solution to this differential equation. So your solution is a function, e to the x. And here's the crazy thing about this function. The crazy thing about this function is that there's an infinite number of solutions. So let's go ahead and test out c times e to the x, some constant, right? Remember, the c is from integrating as well, and you'll learn how to find this c value later. Let's go ahead and test out c. Okay, so let's plug in c, e to the x, into y, right? That's our function. That is our supposed solution. And if you want to take the second derivative of c times e to the x, you need to take the first derivative first. Well, the first derivative of some constant with e to the x, derivatives ignore coefficients, and c is a coefficient here. So the first derivative is just c times e to the x still. And the second derivative is still equal to c times e to the x. So if we plug in c times e to the x, we still get c times e to the x minus c times e to the x. This is still 0, right? You're just subtracting the same thing over and over again. So here's the thing. Our solution for this differential equation has an infinite number of solutions. C can be anything. C can be 2. C can be 3. C could be negative 1 billion. Okay, what's billion? Negative 10 to the power of 9. Yes, that's 1 billion. C could be negative 1 billion. And it would still be an answer. So think about it, right? You can test this out yourself. You could pick whatever value you want for C. You'll still get the answer 0. Right? You'll still get 0. So c times e to the x is the solution to this differential equation. Now, in the previous video, I talked about what a differential equation is, right? And a quick explanation of it is just any equality that has derivatives in it. So y double prime, that's a derivative. So this is a differential equation. But an important key note, what am I saying? Important key note? An important thing to note, not keynote. An important thing to note is that differential equations, ordinary differential equations, have infinite solutions. That is, if you meet a set of specific conditions. But most of the ones that you're going to see in your, well, most of the differential equations that you're going to see will have infinite solutions. Let's say that, okay? And you'll learn about unique solutions, but that's a little bit later. But keep in mind, differential equations have infinite solutions. So that's a little bit different, huh? That's a little bit different from what you've been learning in your other classes. Let's go ahead and take a look at this differential equation right here. And I want you to pick A, B, or C. Which one of these is a solution to the differential equation y prime is equal to x? And I wrote this in another way here for you guys, dy over dx, if you're more comfortable with this notation right here. Right? These are just essentially two of the same things, so don't get confused. But go ahead, try to figure out A, B, or C, which one is a solution to the differential equation. So remember, the solution to the differential equation is a function, right? So the function is y, right? That's the variable we're using for the function. And the answer is A. So I'll show you why it's not the other ones, but let's go ahead and look at A first. So we have x squared over 2 is equal to y. So remember, we want to plug this equation in to these, we want to plug this value for y in to the equation, to the differential equation, and see if you get an equality at the end. So y prime, right? So we have a y prime here. So we don't have to worry about the y. We're not plugging in y, but we're just plugging in y prime. We're seeing if y prime is equal to x, okay? So what's y prime? Well, y prime is the derivative of x squared over 2, which is simply just x. And if we plug in x for y prime, right, y prime is equal to x, so we can plug in x into y prime, we get x is equal to x. And this right here is a solution to the differential equation. And remember how I said differential equations have infinite solutions? What's the infinite solution here? Well, it's just simply if you add a plus c here. So if you add a plus c, what happens? Well, remember, if the original equation is y, we're not really caring about y, right? So this function right here, we're not plugging it in, okay? We're caring about it. We're not plugging it into the equation. So we don't really care what's inside of it for now. Now, here's the thing. If you take the derivative of y, what happens to the arbitrary constant? What happens to the c? It disappears. The c actually disappears, right? So since the c disappears, in y prime, what actually matters, right? Y prime is what we're actually plugging into the differential equation. C is gone. We don't have to care about it. So c can be any constant, and when you take the derivative, c can be any constant, and once you take that derivative, it goes away, and you just get left off with x, right? So plus c right here, x squared over 2 plus c, is the actual solution to the differential equation. This is just one of the solutions, but I didn't want to confuse you with the arbitrary constant since you're just, getting the hang of this concept. But let's go ahead and test out the other things. Why are these not solutions to the differential equation? So e to the x. All right, e to the x. Remember, we're only plugging in y prime, so let's go ahead and find y prime. So y prime is just e to the x again. If we plug in e to the x for y prime, what do we get? We get e to the x equal to x. Well, this is clearly not true, right? So b is not a solution to the differential equation. Let's take a look at this next guy right here. X squared over 4 is equal to y. Let's solve y prime because we have a y prime in our differential equation. We take the derivative of this, we get x over 2. If we plug in x over 2 into the differential equation for y prime, so if we send x over 2 into here, we get left off with x over 2 is equal to x. This is clearly not true. Therefore, the only solution to this differential equation is x squared over 2, and don't forget the plus c. Let's take a look at this differential equation right here, and remember this is just the first derivative, and I want you guys to find out which answer choice is the solution to the differential equation by just plugging and chugging. So once you've done that, I'm going to spoil the answer now, so pause the video if you haven't finished. It's B. It is B. So let's go ahead and test out B. So remember, the solution to the differential equation is a function, and that function is y, correct? So let's look at y. Well, y has the arbitrary constant, but remember when you're taking derivatives with the coefficient, you just ignore the constant. And we want to find y prime. And the reason why we want to find y prime is because we have y prime in the equation. So once we find y prime, what is it? Well, y prime, using chain rule, you get negative 2 times the constant times e to the power of negative 2 x. Right? This right here is the derivative. So this right here is the derivative of y. And now all we have to do is plug these new equations that we found in and see if it meets the condition 0. So let's take a look at this. Let's go right down 1/2 y prime. So y prime is negative 2 c times e to the negative 2x plus y, and y is just c times e to the negative 2x. Okay? And this should be equal to 0. If we distribute the 1/2 into here, so if we distribute the 1/2 into here, we should get negative c e to the negative 2x plus c e to the negative 2x. And now keep in mind, these two exponentials have the same power, right? They have the same power, so we can add and subtract them together. And here's the thing about this. This one is negative, and this one is positive. What happens if we add the positive version onto something to the negative version? You just get, they cancel out. Both of these cancel out, and you actually end up getting 0. So 0 is what we want, right? We want these guys to eventually create an equality. That's what our differential equation is. And notice, the arbitrary constants cancel out as well. So as long as the c values are the same, these guys will always cancel out. And we'll get to 0. So b is the solution to the differential equation. And we tested that by plugging in for the derivatives and seeing if we get our equality right. Let's take a look at this next question. I know, there's so much work. Why did I even click on this video? You're probably thinking that. Why did I even click on this video? Jitty's making me do so much work. Well, you clicked on the video. Let me tell you, you clicked on the video because my voice is beautiful. My voice is so beautiful. Hopefully, that is the reason why I clicked on this video, right? Wink, wink. I don't have a face cam, so that's why I'm saying wink. But now that I think back, it's a little corny to say. But go ahead and solve this problem. Figure out which one, A, B, or C, is the solution to this differential equation. I'm going to spoil it now, so make sure you pause the video if you're still doing it. It's A. So A is the solution to this differential equation. Why is it? Well, let's look at y. So y is equal to c times e to the x squared over 2. Let's bring this a little lower. C times e to the x squared over 2. So this right here is y. We have dy over dx here, which is just another way to write y prime, or the first derivative. So let's go ahead and find y prime. Y prime is simply the derivative of y. And by using chain rule, you get c times x e to the x squared over 2. Okay, so this right here is the first derivative. And by using chain rule, we got this, okay? Now, all we have to do is plug it in. So dy over dx is just y prime. Same exact thing. So let's plug in for y prime here, okay? So we get e to the x squared over 2 is equal to x times y. So y is c times e to the x squared over 2. And we can rewrite the equation on the right side to get c times x e to the x squared over 2. And right here, the two equations are equal, therefore A is the solution to the differential equation. And if you test out anything other than A, B, or C, the answers will not be equal. And I tricked you guys a little bit because I put a negative here. So the negative will not give you an equal answer. But if you get an equality at the end after plugging everything in, thumbs up, that is the solution to the differential equation. So I guarantee you, this will be the last differential equation I'm going to make you solve, I promise. Because if by now you don't understand it, I'm a bad teacher. I don't want to blame it on you. I'm a bad teacher. And also, wait, do not blame your professors, by the way, unless they have like a Rate My Professor score under 2.0. All right, look at Rate My Professors. That stuff actually helps. But if you're watching a differential equation video, you by now probably know what that is. But which one is it? A, B, or C? Okay, spoil C. It is C, and the differential equation, the final answer to the differential equation is C. So let's erase everything, and let's go check this out. Let's confirm it. Is this the solution to the differential equation? So y is equal to this. And we have a y double prime. So we have to solve for double prime, which is the double derivative. So c1 times the derivative of sine, that's cosine. And c2 times the derivative of cosine, well, that's actually negative sine. So we should put the negative in front. All right. So we need to find the second derivative because that's what the equation asks for. That's what the differential equation asks for. So we have y double prime. The derivative of cosine is negative sine, so we should have a negative in front. Sine of x minus c of 2. The derivative of sine is cosine, and we just simply ignore the arbitrary constants because they are all coefficients. All right, let's go ahead and plug this in. Is this actually the solution? So we have y double prime here. Let's go ahead and plug in y double prime c1 times sine of x minus c2 times cosine of x. All right, and we need to add this. Let's actually put this at the top. This is y double prime. We need to add this to y. So what is y? Y is this guy right here, up here. This guy right up here. So we have c1 sine of x plus c2 cosine of x is equal to 0. Is this equal to 0? Okay, and let's section this off. This is right here is just y. All right, so what cancels out? What cancels out? Well, we have negative c1 sine of x, okay? And this is right here is positive c1 sine of x. The constants in the front are the same, and the trig function is the same. So we can cancel these out. All right, how about this? Negative c2 cosine of x, positive c2 cosine of x. These are the same. These have the same arbitrary constant, and they have the same trig function, except one is just the negative of the other. So they cancel out. Oops, gotta redo that. I erased the x there. So they cancel out, and everything cancels out. You just get left off with something. What is that something? 0. And 0 is equal to 0, right? Therefore, this guy right here, our function y, is the solution to this differential equation. Remember, you can solve differential equations by finding the derivatives. Let's not say solve, because you can confirm a solution by solving for the derivatives of that solution, that potential solution, and plugging it into the differential equation. So that's what we've done the entire video. I gave you answer choices, and you found the derivatives, right? All of the answer choices were potential solutions to the differential equation. I gave you the differential equation, and you just plugged in the derivatives, right, of the potential solutions. So, delicious. I just took a sip of water. But anyways, that is the end of the video. Hopefully this helped. If it didn't help, I'm a failure. But anyways, if you have any questions, put it down in the comment section. If you found this video helpful, consider subscribing and liking the video. Also, thank you guys for 467 subscribers. If you're watching this in 2025, you know what I'm talking about. If you're watching this in a couple years later, you're probably going to think I'm cringe. But I'll see you guys in another video.